Hello there and welcome to Science with a Coffee. In this video there will be 8 practice problems that I'll put up on the screen right now from lesson 1 on classifying matter. So if you want, you can write down these 8 practice ones, do them yourself. If you want to pause the video, that is completely okay. And then afterwards I will take them up. Let's go through these answers. So we have salt, iron, salt water, glass, diamond, air, Caesar salad dressing, and graphite. If we're looking at these, let's start with salt. So salt would be a compound. So if it's just salt, it is a compound. So it's different elements all attached to each other. It is not an element because that would mean that salt is made out of just one element, which it's not. It's made out of sodium and chlorine, or sodium chloride. So because there's 2 elements together, automatically makes it a compound. Now, if there's nothing else with that salt, it is pure. Iron, it's just iron. And iron itself is, sorry for the squeaky marker, is just Fe on the periodic table. So what that means is its own element. It's nothing else with it. Now, salt water gets a little more complicated because we now have what we talked about before with salt, and it's dissolved in water. So that brings us over here with a mixture, because now we have basically 2 compounds together now. We have salt and water together. Because of that, it is not just purely one of them, it's both. Now, with most salt water, you cannot actually see the different components, so it would be a homogeneous mixture. Now, if there's so much salt in there that you can actually see the salt sitting in the glass or whatever, then yes, it could potentially be heterogeneous. But if it's just salt water like the sea, and you can't see anything other than just the water, so for instance, going back to our water example, this is actually tap water, so inside here there is actually some salts. Now, glass. This one's tricky. I don't know if you guys got this one. Glass, most glass, squeaky sound, is made out of silicon dioxide. Silicon dioxide is actually 2 different elements together, so it is a compound. Now, it's one of the coolest things ever, because how you can take something like sand, heat it up, melt it, and make glass is beyond me. Craziness. Anyways, glass is a compound. Then you have diamond. Now, you're probably thinking to yourself that a diamond is a compound. And if you're thinking that, unfortunately, you would be incorrect. Diamond is actually only, if it's a pure diamond, it is only made out of carbon. So diamond is actually something fancy called an allotrope, and we'll probably get into that in a different lesson. But diamonds are just atoms of carbon. Diamond can actually be impure. So if you have a really good diamond, it's clear, it's colorless, it's a flawless diamond, it will be just carbon. Now, there's some fancy diamonds out there that have very, very small impurities, as in it's making it not pure. Those can change the color of the diamond. A very famous one is the one like from the Titanic diamond. Anyways, it's really big and it's blue. It's blue because it actually has trace amounts of boron in it. That boron changes how the light goes through it, blah, 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 turns it blue. So, pure diamond is pure carbon. The air around us. Now, the air around us is actually made out of different elements or compounds, but because they're all together and you can't see the different parts of them, it's actually a homogeneous mixture of all of those things. Now, depending on where you live and the air quality, it might actually sometimes be kind of heterogeneous. So if you see a lot of smoke in the air, if you see a lot of pollution in the air, you can actually see those different things. Typically, the air you should see should be homogeneous. And Caesar salad dressing. If your Caesar salad dressing is properly made, you should see the different things in it. So you should see some pepper, you might see some chunks of cheese, like Parmesan, you might see the different fatty bits. Sometimes your Caesar salad dressing can separate a little bit, so you can see the oil and you can see the vinegar, stuff like that. Anyways, usually, typically with Caesar salad dressing, you can at least see the white cream stuff and pepper, typically. So I would classify your classic Caesar salad dressing as heterogeneous. And then lastly, graphite. So the stuff inside pencil, it's not lead. With graphite, it's sneaky, and this is how I spice this up a little bit for you, is this graphite is actually a different bonding pattern, if you will. That's exactly what it is, but you get the idea. Different bonding pattern than diamond, but this is still carbon. So if I took the center of this pencil, heated it up really hot, applied a bunch of pressure, and cooled it down at the right rate, I could make diamond. It's actually made out of the same thing. Both of these are just made out of carbon. So they're both pure substances typically. Now, those are all the examples. Thanks for sticking with me this long. I hoped that practice helped with the explanation after going through them. So again, to recap, salt is a compound. Iron would be a pure element. Salt water would be salt and water, which would make it typically homogeneous because now you have two compounds together that you wouldn't see the different parts of. Glass is a compound typically. Now if you have fancier glass, it would be a homogeneous thing if you put stuff in the glass, so like the sapphire glass on iPhones that has other things in it to make it stronger. Diamond is pure carbon. Pure carbon would be an element. Air is typically, hopefully, homogeneous or homogeneous. Caesar salad dressing, again, hopefully heterogeneous. And then graphite would, again, be a pure element. You can't see the different things, and it's all made out of carbon. I hope that video helped clarify some of your understanding from lesson 1 on the classification of matter. And as always, please subscribe, hit the bell, and don't forget to be the ball.